Hello, Physics Nation. My name is Nate Larmond, and I'd like to do part 6 of our epic truss analysis. We have just, well, we found the force in this guy, and this guy, and this guy, and this guy, and we are down to 3 members. So do you want to do the pin joint at D, or do you want to do the pin joint at A? Well, the trouble with D is there are 2 diagonal forces. So both of these 2 members have horizontal and vertical components. So we could do the sum of the forces in the horizontal direction and then the sum of the forces in the vertical direction. And we could have 2 equations and 2 unknowns and do a little system of equations. Or we could just go to pin joint A and do some much more simple math, and that's what I'm suggesting. So knock yourself out if you want to do a system of equations up in pin joint D, but I'm not interested in that. I am going to go to pin joint A in the lower left here. So we actually found this reaction force, I don't even know, back in part 2, I think. We did the sum of the forces in the y direction for the entire structure. So we have 3 downs, and then we did a torque balance to find the reaction force at the roller joint, and then we just did the sum of the forces in the vertical direction has to add to 0. So we found this reaction force to be positive 975 pounds. Well, there's only one other vertical force, and that's the vertical component of this guy. And you know, the goal is to see right triangles everywhere. What percentage of this diagonal force is down? Well, 71%, or root 2 over 2. And that's, you know, the annoying part. You just have to know that the vertical component is hypotenuse, 100% of the force, multiplied by sine of theta. You can actually do sine of 225 right here, or you can just put a negative sign in and do sine of 45 like we did. So this is static equilibrium. There are only 2 vertical forces. We have a positive 975 and then a negative vertical component from this force. Subtract 975 from both sides, divide both sides by negative 0.707 or negative root 2 over 2, and you get 1,379 pounds. That means our assumption of compression was correct. If you get a positive answer after you assume the direction, that means you assume the correct direction. Remember, FAD is in compression. It is pushing negative x, negative y with a force of 1,379. And we can preview our last one. That means the same force is pushing positive x, positive y, 1,375 pounds in compression is now acting northeast. And I think that's going to be our last video. Or maybe we'll come down here and we'll find this guy. Anyway, we're pretty close. We're only 2 members away to wrap up our series. Thanks for watching. See you in the next video.